The most promising place to search for alien life may be a black ocean trapped under miles of ice, not a green world, not a warm little Earth with clouds and continents, not a planet where sunlight falls on leaves, rivers, soil, and air. The place that keeps pulling scientists back is colder, darker, and far more difficult to imagine. It is a moon locked inside Jupiter's power, a pale sphere scarred with rust-colored cracks, shining in the distance like a broken bone. Europa looks dead from far away. It is smaller than Earth's moon. Its surface is frozen. Its sky, if you could stand there long enough to see it, would be dominated by Jupiter, a planet so enormous it would not feel like something hanging overhead. It would feel like a wall. A moving, striped, storm-filled wall of gravity and radiation, filling the darkness with a presence too large for comfort. Europa is not a place built for human romance. It is not gentle. The sun is weak out there, reduced to a brilliant point. The surface temperature is so low that ordinary water ice becomes stone-hard. Jupiter's magnetic field sweeps charged particles across the moon, bombarding its surface and rewriting its chemistry. There is no forest, no visible sea, no breathable air, no blue sky, and yet beneath that silent ice, there may be more liquid water than in all the oceans of Earth. That is the reason Europa will not leave science alone, because life, as far as we know it, does not begin with beauty. It begins with conditions. It needs a solvent, a way for chemistry to move and mix. It needs elements that can build complex molecules. It needs energy that can push matter out of stillness and into reaction. Earth has all of that under sunlight, but Earth also has it in places where sunlight never arrives. At the bottom of our own oceans, life gathers around chemical heat rising from the planet's interior. Tubeworms, microbes, clams, and strange communities live in darkness, not because the sun reaches them, but because chemistry does. That fact changed the way people looked at Europa. Before deep-sea vents were understood on Earth, a world without sunlight seemed like a poor candidate for life. The imagination wanted warmth from a star. It wanted a surface ocean, weather, maybe an atmosphere enough to hold a horizon. But biology on Earth kept showing that life is more stubborn than human expectation. It survives in acidic water, frozen depths, radioactive rock, boiling springs, deep crust, crushing pressure, and darkness. It does not need human comfort, it needs opportunity. Europa may have opportunity hidden under ice. The question is whether the hidden ocean is only water, or whether it is a world. Imagine falling toward Europa from space. Jupiter fills more and more of the view. Its cloud bands twist like storms seen from a god's height, cream and orange and brown streaked with violence. The great red spot, larger than Earth, rotates in the distance like an old wound. Around Jupiter, radiation belts move invisibly, but the spacecraft feels them. Electronics must be shielded, instruments must survive. The moon ahead grows from a point into a white disk, then into a landscape. There are no mountains like the Himalayas, no continents, no green valleys. The surface is ice, but not simple ice. It is crossed by long dark lines, double ridges, reddish stains, broken plates, chaotic terrains where the crust seems to have fractured, shifted, and frozen again. It looks like a frozen ocean that was shattered and badly repaired. Some regions resemble ice floes on Earth's polar seas, except the scale is planetary and the ice may be hiding an ocean that never sees the sky. The strange thing about Europa is that it does not look as old as it should. Many moons in the outer solar system are battered with craters, each impact preserved for billions of years like scars on stone. Europa has craters, but not nearly as many as a completely dead surface should carry. Something has been renewing it. Something has disrupted the ice, erased old scars, lifted material, shifted plates, opened cracks, and closed them again. The moon is not geologically silent in the way a frozen rock should be. The ice has a memory of movement. That movement points downward. Europa's surface tells us that the moon is not just a frozen ball. It is a shell. The ice is the outer skin of a deeper system. Beneath it, evidence from spacecraft measurements and planetary physics strongly suggests a global salty ocean, wrapped around a rocky interior. The ocean does not have to be visible to make itself known. A conductive saltwater layer inside Europa can respond to Jupiter's magnetic environment. The moon's surface geology speaks in broken patterns. Its density and shape point to internal layers. Its relationship with Jupiter explains why it may still have heat. The source of that heat is not the sun. It is Jupiter's grip. Europa orbits inside a gravitational machine. It is tugged not only by Jupiter, but also through an orbital dance with neighboring moons, especially Io and Ganymede. These relationships keep Europa's orbit slightly stretched instead of perfectly circular. As Europa moves closer to and farther from Jupiter during each orbit, the giant planet's gravity flexes the moon. The body of Europa is squeezed and released again and again through geological time. A small flex, repeated endlessly, becomes heat. This is tidal heating. It is not gentle, but it is also not random. It is the same broad physics that makes Jupiter's moon Io the most volcanically active world in the solar system. Though Io expresses that heat in fire and sulfur while Europa hides its energy under ice. Europa's flexing can warm its interior enough to help maintain liquid water beneath the frozen shell. Without that internal heating, the ocean might have frozen long ago. With it, Europa becomes a place where the deep may remain liquid across immense spans of time. Time matters. A short-lived puddle is not the same as an ocean that persists. Life, if it begins at all, may need stability. It may need countless cycles of chemistry. It may need minerals, energy gradients, and protection from destructive radiation. Europa's ocean, if it has been present for much of the moon's history, would not be a passing accident. It would be an environment, dark, alien, inaccessible, but possibly continuous. That is what gives the moon its power, not proof of life, not even evidence of life. A possibility with weight. The surface is hostile, but it may also be useful. Jupiter's radiation attacks Europa's ice and any molecules on it, breaking them apart and creating oxidants and other reactive materials. On the surface, radiation is destructive. For exposed life, it would be devastating. But if those altered materials can be transported down through the ice into the ocean, they might become chemical fuel. A world can be deadly in one layer and nourishing in another. This is the strange double nature of Europa. The very radiation that makes its surface so dangerous may help produce ingredients that an ocean ecosystem could use. If there is a path between surface and sea, that path is one of the great unknowns. Does the ice shell mix? Do cracks reach deep enough? Does warm ice convect slowly over time, carrying surface material downward? Do pockets of briny water rise toward the surface and freeze again? Are the reddish stains on the ice salts or sulfur-bearing compounds or radiation-processed material from below? Does the ocean talk to the surface, or is it sealed away behind a wall too thick for meaningful exchange? The answer matters because water alone is not enough. A sterile ocean is possible. A world can have liquid water and still be chemically poor, energetically starved, isolated, or hostile to biology. Europromismus depends on exchange between rock and water, between surface and ocean, between heat and chemistry. A deep ocean sitting forever under ice may be less interesting if it never touches the rocky seafloor and never receives useful oxidants from above. A deep ocean circulating through fractures in warm rock, reacting with mineral, absorbing chemicals from the surface, and maintaining energy gradients becomes something else entirely. It becomes a candidate for habitability. That word is often misunderstood. Habitability does not mean life exists. It means the conditions might support life as we understand it. It is a careful word, a disciplined word. Europa Clipper, the spacecraft NASA launched toward Jupiter's icy moon, is built around that word. Its mission is not to fly past Europa and announce alien organisms. It is not carrying a magic life detector that can see microbes through miles of ice. It is designed to investigate whether Europa has the ingredients and environments that could support life. That distinction is not a technicality. It is the boundary between science and fantasy. Europa Clipper will study the ice shell, the ocean beneath it, the composition of the surface, the geology of the moon, and the way Europa interacts with Jupiter's magnetic environment. It will fly past the moon many times, not settling into orbit around Europa itself because Jupiter's radiation environment is brutal. Instead, it will orbit Jupiter and make repeated close passes, gathering different views and measurements with each encounter. Cameras will map the surface. Spectrometers will examine composition. Ice-penetrating radar will probe the shell for structures and possible pockets of water. Magnetic and plasma instruments will help constrain the ocean. Gravity measurements will reveal clues about the interior. It is not a descent into the ocean. It is a long interrogation from above. That may sound disappointing until you remember the scale of the problem. Europa's ocean is not under a thin crust of pond ice. The ice shell may be many kilometers thick, perhaps tens of kilometers in places, and its structure remains one of the mission's central mysteries. Drilling through it is not just hard. It is a planetary engineering problem under radiation, distance, contamination concerns, uncertain terrain, and crushing cold. A lander would have to survive on a hostile surface. A cryobot would have to melt through unknown ice for years while remaining sterile enough not to contaminate the very ocean it hopes to study. Communication through ice would be difficult. Power would be difficult. navigation would be difficult. Every step would be difficult. So Clipper does what science often does before it touches a place. It listens, it reads the surface like a frozen document. It searches for places where the ice may be thin, disrupted, warm, young, or chemically connected to the ocean. It asks whether Europa is a sealed vault or a breathing world. It looks for the fingerprints of salt, organics, oxidants, sulfur compounds, water ice phases, and geological processes. It asks how thick the shell may be. It asks whether the ocean is global. It asks whether the moon's interior has the chemistry needed to make habitability more than a slogan. The most dramatic part of Europa may never be photographed. It lies below the surface, beneath ridges and cracks, below radiation-scared ice, below layers that may have shifted and refrozen for millions of years. To reach it in imagination, you have to leave sunlight behind. You have to sink through ice that creaks under tidal stress, past frozen fractures, trapped brines, pockets of salty slush, minerals caught in white and brown layers. Above you Jupiter pulls. Around you the moon flexes. The ice is not dead material. It is a slow-moving shell under pressure. Then the light vanishes. The ocean begins not with waves under an open sky, but with blackness. No sunrise touches that water. No wind moves across it. There are no storms like Earth's surface oceans, no moonlit reflection, no blue horizon. The ceiling is ice. The floor may be rock far below. Between them lies a global ocean under pressure, moving through darkness around an entire moon. If it is salty, it may conduct electricity. If it circulates, it may carry heat and chemicals through the interior. If it contacts the rocky mantle, water-rock reactions may create chemical gradients, perhaps producing molecules that life on Earth can use in deep environments. But every sentence about that ocean has to carry caution: may, might, could, possibly's. Words are not weakness, they are honesty. We have not sampled Europa's ocean. We have not seen its seafloor. We have not measured a vent. We have not found a cell. The ocean may be habitable, or it may be missing something essential. Some recent scientific work has raised difficult questions about whether Europa's rocky seafloor experiences enough deformation or chemical cycling to provide the energy sources that optimistic models require. Other models keep the possibility alive through different mechanisms, including radiogenic heat, tidal processes, oxidant delivery, and water-rock chemistry. The argument is not settled that uncertainty is the real story. Europa is not a simple problem. It is a problem with a beautiful surface. The human mind wants to turn the black ocean into a scene. It wants glowing vents, drifting organisms, a biosphere under ice. Deep sea life on Earth makes the temptation stronger because it gives us imagery. Hydrothermal vents on our planet are among the most alien places we have ever filmed. Chimneys pouring mineral-rich fluids into cold black water. Microbial mats capturing chemical energy. Animals clustered around warmth in darkness. It is easy to take that image and place it under Europa's ice. But science cannot do that. Earth's vents are not proof of Europa's vents. Earth's microbes are not evidence for European microbes. Similarity in one requirement does not guarantee similarity in outcome. The deep ocean on Earth is connected to a living planet with continents, plate tectonics, a long biological history, and a surface transformed by life. Europa is different in almost every visible way. Its ocean may have water and rock, but the chemistry, energy, pH, salinity, redox balance, seafloor activity, and history may not match Earth's deep sea. That does not make Europa uninteresting. It makes it more serious. A fantasy world gives easy images. A real world resists. Europa forces scientists to ask what life truly needs. When sunlight is removed from the equation, it strips habitability down to harder things: liquid water, chemistry, energy, stability, transport, boundaries, gradients. It asks whether life is a surface phenomenon of warm planets, or whether biology can emerge wherever water and rock have enough time to exchange energy. That is why a moon can become more important than a planet. In the old imagination, the search for life was about Earth-like worlds around sun-like stars. Europa helped break that frame. So did Enceladus, another icy moon, spraying material from its hidden ocean into space. So did Titan, with its methane lakes and thick atmosphere. Strange not because it looks habitable in the usual sense, but because it shows how diverse planetary chemistry can be. The solar system is no longer a set of dead rocks with Earth as the exception. It is a system full of environments. Some are dry, some are frozen, some are chemically rich, some are active in ways no one expected before spacecraft arrived. Europa is the dark ocean version of that lesson. The surface looks like a locked door. The moon says nothing. Then the cracks appear. Those cracks matter. Long ridges stretch across Europa for hundreds or thousands of kilometers. Some appear as paired lines with darker material between them. Some terrains look broken into plates that shifted and rotated, as if blocks of ice floated in softer material. The reddish-brown colors in fractures may come from salts or other compounds altered by radiation. Their exact composition is still being studied, but their presence hints at chemical processes beyond pure water ice. A smooth dead ice shell would be less compelling. A fractured, stained, resurfaced shell suggests motion. Motion suggests heat, stress, exchange, or at least a history of disruption. The question is how deep that disruption goes. If cracks remain shallow, they may tell us about the surface but not the ocean. If some structures connect to deeper reservoirs, they may become windowers. If materials from below reach the surface, spacecraft can study the ocean indirectly without touching it. That possibility is one reason Europa's surface composition is so important. A moon with a hidden ocean is hard to study. A moon that leaks its chemistry onto the surface becomes more generous. There have also been reports suggesting possible water vapor plumes at Europa, though the evidence has been more difficult and less consistent than the dramatic plumes at Enceladus. If Europa does produce plumes, even intermittent ones, they could offer an extraordinary opportunity: ocean or subsurface material thrown into space, available for spacecraft to sample during a flyby. But here again, caution matters. Plumes are not guaranteed. Their presence, frequency, source depth, and composition remain uncertain. Europa should not be sold as a moon constantly spraying its ocean into space. The honest version is more tense. Clipper may fly over a surface that holds clues but keeps its deepest secrets below. It may find evidence of exchange, or it may find a shell more complicated and more sealed than hoped. It may detect shallow water pockets or only layered ice. It may strengthen the ocean case, refine its depth and salinity, map regions of recent activity, and identify chemical ingredients on the surface. It may show that Europa is more habitable than we knew, or expose reasons for caution. Either outcome would matter. A less habitable Europa would not be failure. It would teach us what ocean worlds require. A more chemically connected Europa would sharpen the case for future missions. Science is not only the confirmation of hope, it is the removal of bad assumptions. Still, the hope is hard to avoid because Europa is close enough, in cosmic terms, to feel reachable. Exoplanets around distant stars are reduced to light curves and spectra. Europa is a world in our own solar system. Spacecraft have seen it. Future spacecraft can return. One day, perhaps, a lander could touch the ice. One day, a mission might sample fresh material from a plume or a recently fractured region. One day, technologies may be built to descend through ice. The ocean is not reachable now, but it is not beyond imagination forever. That makes Europa different from a distant biosignature candidate. It is not just a question in starlight. It is a place we can keep approaching. Picture Europa Clipper during a close pass. The spacecraft is moving fast. Jupiter's radiation environment presses on every electronic system. The moon sweeps below, white and rust and black, the surface passing too quickly for romance. Instruments open their narrow windows of opportunity. Radar pulses downward, looking for echoes from layers inside the ice. Cameras gather strips of terrain. Spectrometers split reflected light into composition. Fields and particles instruments sense the invisible electrical and magnetic conversation between Europa and Jupiter. Then the flyby ends. Europa falls behind. The spacecraft arcs away around Jupiter, carrying a little more knowledge back through the darkness. Another pass will come, another angle, another strip of ice, another chance to ask the same moon a slightly different question. That rhythm matters because Europa is not easily understood from a single glance. Its surface is varied. Some terrains may be ancient, others younger. Some regions may reveal salts, others radiation products. Some fractures may be active or geologically recent, others relics of processes long gone. The shell may vary in thickness. The ocean may interact with the ice differently in different places. A world that appears simple from far away becomes complicated when mapped close. Complication is good. Life, if it exists somewhere, probably does not appear where conditions are simple and static on Earth. The richest environments often occur at boundaries, where water meets rock, where hot meets cold, where oxidants meet reductants, where light meets shadow, where chemistry is driven away from equilibrium. Europa is interesting because it may be a world of boundaries. Ice and ocean, ocean and rock, radiation-processed surface and protected interior, tidal stress and frozen shell. Darkness and energy, but being interesting is not being alive. That line must stay clear. A moon can have water and no life. It can have chemistry and no life. It can have energy and no life. It can have all the ingredients we recognize and still fail to cross the threshold into biology. The origin of life may require rare circumstances. It may need cycles of wetting and drying that Europa does not provide. It may need surfaces, minerals, concentrations, or temperature gradients in arrangements that an ice-covered ocean lacks. It may have happened easily on Earth but not everywhere. Or it may happen whenever conditions are right, and Europa may be one of many dark oceans in the galaxy where biology could take hold. We do not know. That is the honest pressure behind the entire mission. The search for life is often described as a quest for an answer, but much of the work is about making the question sharper. Is there life? Is too large at the beginning? Europa Clipper breaks it down. How thick is the ice? Is there liquid water within or beneath it? What is the ocean's salinity? What compounds are on the surface? Are there organics? Are there oxidants? Is there recent geological activity? Is the ocean in contact with rock? Is there enough energy? Are there pathways for exchange? Each answer changes the next question. If the ice shell is thin or locally broken, future missions might target those regions. If the shell is thick and stagnant, the ocean becomes harder to access and perhaps harder to nourish. If surface materials suggest salts from below, the surface becomes a chemical archive. If organics are found, scientists will ask whether they were delivered by impacts, produced by chemistry, or transported from the ocean. If no strong evidence of exchange appears, habitability becomes more uncertain. If radar reveals complex internal structures, the moon becomes more dynamic. Europa does not have to provide a single revelation to transform astrobiology. It may do so by changing the odds. There is a particular kind of fear in studying a place like Europa. It is not horror, it is scale. The idea of a black ocean under miles of ice is physically oppressive. On Earth, the ocean's surface gives us a way to think about the sea, waves, ships, storms, coastlines, light. Europa removes all of that. There is no open surface, no air-water boundary, no horizon. The ocean is buried. Its ceiling is a planet-wide shell. Its darkness is not night, because night implies the possibility of morning. It is permanent. If life exists there, it has never seen the star. That idea is almost unbearable. A living thing in Europa's ocean, if such a thing exists, would not know Jupiter as a giant in the sky. It would not know the sun. It would not know the ice as a landscape. Its universe would be water, pressure, chemistry, boundaries, perhaps warmth near rock, perhaps currents carrying dissolved molecules through blackness. It would be alien not because it had tentacles or glowing eyes, but because its entire experience of reality would be sealed away from everything we associate with worlds. But that image must remain clearly marked as imagination. It is a way of feeling the stakes, not a claim about what is there. The real Europa may be empty. Its ocean may be a dark chemical reservoir with no biology at all. If so, that emptiness would still speak. It would tell us that water and time are not enough. It would push scientists to ask what Earth had that Europa lacked. It would make the origin of life seem more specific, perhaps more fragile. The absence of life in a promising ocean would be a profound result, though proving absence is far harder than finding presence. A sterile Europa would not make the universe dead. It would make the rules more demanding. A habitable Europa with no life would be one kind of revelation. A barely habitable Europa would be another. A Europa with evidence of active exchange and rich chemistry would raise the pressure for future missions. A Europa with even indirect evidence of biology would change everything. But that last step is far beyond what can be responsibly claimed now. There is a reason careful scientists speak slowly about this moon. The public wants the ocean to mean life. The mission asks whether the ocean can support life. Those are different sentences. The difference is the whole discipline. Europa has been pulling at human imagination since spacecraft gave us better views of its surface. Before that, it was a point of light in telescopes. One of the 4 large moons Galileo observed orbiting Jupiter in the early 17th century. Those moons helped shatter the old idea that everything revolved around Earth. In a strange historical echo, Europa may now help shatter another human assumption. That life-bearing environments must resemble Earth's surface. The same moon that once helped move Earth away from the center of the cosmos may help move Earth-like conditions away from the center of biology. That is not because Europa is known to be alive. It is because Europa expands the map of where life might be possible. The search for life beyond Earth is often a search against our own instincts. We are surface creatures. We live under sunlight. We breathe air, we measure days by sunrise and sunset, we think of oceans as open water under sky. Europa asks us to imagine an ocean with no sky, we think of habitability as warmth. Europa asks us to think about energy under ice, we think of planets as the main characters. Europa reminds us that moons can hold worlds inside them. A buried ocean is not less real because no one can see it. It may be more common than surface oceans across the galaxy. Large icy moons may orbit giant planets in huge numbers. Some may be warmed by tides, some may have internal
oceans, some may last for billions of years.
If life can exist in buried, then the universe's habitable real estate may be much larger than the number of Earth-like planets in sunny orbits. The most common homes for biology might not have blue skies at all. They might be dark, sealed, and invisible from a distance. That possibility is both thrilling and troubling. Thrilling, because life may have more chances than we once thought. Troubling, because hidden life is hard to find. A biosphere under ice does not easily announce itself across interstellar space. It may not produce oxygen in an atmosphere. It may not change a planet's color. It may not send signals. It may live and die in darkness, leaving no obvious mark for distant telescopes. If ocean worlds are common and inhabited, the galaxy could be full of life that remains silent. Not because it is intelligent and hiding, but because it is buried. Europa could be a local test of that cosmic problem. If a world in our own solar system has a hidden ocean, and we struggle this much to assess its habitability, imagine trying to recognize similar worlds around other stars. We may miss them entirely. We may classify them as icy bodies, dull moons, unremarkable companions of giant planets. The places where life survives may not be the places easiest for astronomy to see. There is a deep irony in that. The best nearby candidate may be one of the hardest environments to access. The mission to Europa is therefore not only about Europa. It is about learning how to read hidden worlds. It is about developing the language of ice shells, induced magnetic fields, surface chemistry, radar echoes, plume searches, and geological youth. It is about building a toolkit for life that does not live under a sky. The ice itself becomes a kind of text. Cracks, ridges are punctuation. Chaos terrain is a torn page. Dark stains are chemical notes written by processes we do not yet fully understand. Radar echoes may reveal buried layers, pockets, or structures. Magnetic measurements may tell us about the depth and salinity of an ocean never seen. Spectra may identify compounds that came from below or were altered above. Each measurement is incomplete, but together they can form a portrait, not a portrait of life, a portrait of a world that might allow life. That is the discipline of restraint. It would be easy to make Europa into a monster story. A black sea under ice invites fear. The pressure, darkness, radiation, and distance create a natural sense of dread. But the real moon is more unsettling than fiction because it does not need monsters. Its strangeness is physical. A global ocean hidden beneath a frozen shell, pulled and heated by a giant planet, chemically altered by radiation, crossed by fractures, approached by a spacecraft that must dart through a hostile environment. Nothing invented is needed. The facts are already cinematic. What they are not is conclusive. On Earth, every living system we know depends on liquid water. That makes Europa's ocean impossible to ignore. But Earth also teaches another lesson. Life is not just water around carbon, it is organization, it is metabolism, it is information, it is chemistry that maintains itself, copies itself, evolves, and changes its environment. The leap from ingredients to life is immense. Science does not yet fully understand how that leap happened here. That ignorance travels with us to Europa. We cannot simply say, there is water so there may be life, and stop. We have to ask what kind of chemistry happens there, whether molecules can concentrate, whether energy is available at the right rates, whether the ocean has been stable long enough, whether harmful conditions overwhelm helpful ones, whether surfaces and minerals provide catalytic settings, whether chemical disequilibria exist, whether oxidants from the surface meet reductants from the seafloor, whether the system is dynamic enough to feed complexity without destroying it. Europa is not a yes or no question, it is a chain of difficult conditions. The ice shell sits at the center of that chain. Too thin, and the ocean may exchange readily with the surface, but the shell's history and stability become complicated. Too thick, and access becomes difficult, both for chemistry and for future exploration. If the ice convex, materials may cycle slowly. If it is stagnant, the ocean may be more isolated. If brines migrate through cracks, the surface may preserve oceanic chemistry. If radiation destroys or modifies those materials beyond recognition, interpretation becomes harder. The shell is not just a barrier, It is a filter. It may protect the ocean from radiation while also limiting the delivery of useful oxidants. It may preserve biosignatures or erase them. It may allow pockets of liquid water within the ice, creating smaller habitats separate from the main ocean, or it may remain mostly frozen and dry except for ancient fractures. It may hold records of ocean composition, or it may mostly record surface radiation chemistry. Every possible answer creates new tension. The ocean below is also not simply an ocean. Its depth may be enormous, its pressure may be extreme, its salinity may differ from Earth's oceans, its pH may be acidic, alkaline, or varied. Its circulation may be shaped by rotation, heat flux, salinity gradients, and interactions with the ice above and rock below. If hydrothermal activity exists, it may be sparse, weak, or widespread. If the seafloor is too rigid or chemically inactive, energy sources may be limited. If water-rock reactions are strong, the ocean may be chemically rich. We do not know which Europa we will meet. That is why every flyby matters. The spacecraft will not answer everything, but it can narrow the possible Europas. It can distinguish between a shell that looks globally thick and quiet and one that shows signs of complexity. It can map regions that may have recent resurfacing. It can identify compositions that suggest internal material. It can search for thermal anomalies, though subtle ones may be difficult. It can test whether radar reflections reveal structures beneath the surface. It can improve estimates of the ocean's properties through fields and gravity. A moon becomes less mythical when its unknowns become measurable. That is what exploration does at its best. It does not always give immediate answers. It gives sharper ignorance. Before spacecraft, Europa was a small bright point. After Voyager and Galileo, it became an icy world with cracks, ridges, chaos terrain, and strong evidence for an ocean. After Europa Clipper, it may become a mapped system with known chemical provinces, interior constraints, shell structures, and habitability assessments. The ocean may still be unseen, but it will no longer be imagined in the same vague way. The darkness will have shape. There is a moment in deep-sea documentaries when the camera descends beyond the last sunlight. Blue fades to black. The surface world disappears. The pressure increases. Every light becomes artificial. Creatures, if they appear, seem not like animals in a familiar sense, but like solutions to darkness. Europa invites a similar descent, except the camera cannot yet go there. The descent happens through data, through physics, through instruments reading from above. We descend by inference. The ice is the water column. Radar is the light. Magnetism is the current. Surface chemistry is the sample jar. Gravity is the map of hidden mass. Every instrument becomes a way of lowering human thought into a place our machines cannot yet enter physically. That makes Europa's story slow. It is not the pace of a movie. It is the pace of planetary science. Years of travel. Minutes of flyby. Months of analysis. Papers that disagree. Models revised. Instruments calibrated. Surface maps compared. Old assumptions reopened. Young scientists spending careers on one moon's ice shell. Public excitement rising and falling with headlines that can never hold the full uncertainty. But slowness is not emptiness. A black ocean under ice is not less dramatic because it requires patience. The drama is that the answer may exist and still be inaccessible. A living ocean, if present, would not care how difficult it is for us to reach. It would not make itself visible. It would not organize a sign for human instruments. It would simply be there, running on chemistry under a frozen roof, separated from the stars by ice and time. The possibility is almost insulting to our need for clarity. The universe often hides the important things. Earth itself teaches that. For most of human history, no one knew about microbial worlds in deep rock, hydrothermal ecosystems, plate tectonic recycling, or the chemical complexity of the abyss. The living Earth was larger than the human senses. We lived on a planet and still misunderstood where life could be. Now we approach Europa with instruments, models, and humility learned from Earth's own hidden places. Humility matters because analogy can mislead. Europa is not Antarctica. It is not Lake Vostok. It is not Earth's abyss. Those places help us think, but they do not define what must exist. Under Antarctic ice, lakes are shaped by Earth's climate, geothermal heat, sediments, atmosphere, and biology. Europa's ocean is shaped by Jupiter radiation, tidal flexing, ice dynamics, and a different geological history. If life exists there, it may use strategies we understand only partly. If life does not exist, Earth analogs may have made the moon seem more inviting than it truly is. The analogs are bridges, not answers. A serious Europa documentary must resist both extremes. It cannot say the moon is alive. It also cannot dismiss it as just ice. The evidence for an ocean is too strong to ignore. The energy sources are plausible enough to investigate. The surface is active enough to question. The chemistry is complicated enough to matter. Europa sits in the rare category of worlds where ignorance is not empty speculation. It is built from real measurements. The world is asking for another look. That is why Europa Clipper exists. The spacecraft is not going because Europa is known to host life. It is going because Europa may hold a combination that is rare and profound: liquid water, a rocky interior, chemical ingredients, and long-term energy. Each part can be questioned, refined, and tested. The mission's genius is not that it promises a sensational answer. It promises a disciplined assessment of habitability. Habitability is a quieter word than life, but it may be the more important step. Before humanity can find life elsewhere, it has to learn which worlds deserve deeper pursuit. It has to sort the merely wet from the chemically alive, the temporarily melted from the stable, the sealed from the connected, the interesting from the truly promising. Europa is a training ground for that judgment. It will teach us how easily hope survives contact with data. There is another layer of difficulty that rarely appears in simple discussions: contamination. If humans ever send a lander or a probe deeper into Europa's ice, the mission must avoid carrying Earth life into a potentially habitable environment. The search for life beyond Earth has a moral and scientific problem built into it. The same machines that could discover alien biology could also contaminate the place before discovery. A sterile ocean, if contaminated, might become impossible to interpret. A living ocean, if disturbed, raises even deeper questions. Protection is not only about preserving science. It is about respect for a world we do not understand. Europa is remote but not meaningless. A black ocean under ice, even sterile, is a natural system with its own history. The urge to explore must be paired with care. The desire to know cannot become permission to damage. Planetary protection may sound bureaucratic, but in a place like Europa it becomes almost philosophical. If there is even a chance of an independent biosphere, then humanity is approaching something more than a target. It is approaching a possible second origin, a separate experiment in life. No one should touch that carelessly. For now, we remain above the ice. That distance creates its own mood. Europa is near enough for spacecraft, far enough to remain unreachable in the ways that matter most. It lets us see the door but not open it. It lets us infer the ocean but not enter it. It lets us ask whether life can exist there but not easily. It gives science one of its most painful situations. A question that may be answerable, but not yet. The moon keeps its dignity by refusing speed. Jupiter's role in all this cannot be separated from the story. Without Jupiter, Europa might be a frozen moon with a dead interior. With Jupiter, the moon is trapped in a giant's field, stressed, heated, irradiated, and chemically altered. The same planet that makes Europa dangerous may also make it interesting. Gravity warms, radiation damages and manufactures chemical possibilities. Orbital resonance maintains the flexing. The environment is brutal, but brutality can create gradients, and gradients are where chemistry finds work to do. This is not a comfortable kind of habitability. It is not a garden. It is a pressure system, a machine of ice, ocean, rock, radiation, and gravity. If life can arise there, it would force us to loosen our emotional definition of a living world. It would mean biology can belong not only to sunlight and air, but to hidden oceans under giant planets. It would mean the surface of a world may be the least important part. That idea changes the way we look outward. A planet's beauty from space may be irrelevant. A moon's dead surface may hide its real story. The places that look most inviting to human eyes may not be the places where chemistry has the best chance. Europa is a lesson in distrust. Do not trust surfaces. Do not trust first impressions. Do not trust Earth-shaped longing. Look for water, energy, chemistry, time, and exchange. Look below. The ice cracks are a demand to look below. One of the reasons Europa feels so alive in the imagination is that its surface is not smooth perfection. It is wounded. The long reddish lines cut across the globe like stress made visible. They are not random decoration. They are records of force. Somewhere in those lines may be information about the ice shell's thickness, the tidal stresses acting on the crust, the movement of material, and the possibility of brines or ocean-derived compounds reaching the surface. The moon's face is a map of tension. A dead world can have a history. Europa may have a hidden one. In some regions, the surface appears jumbled, as if plates of ice were broken apart and embedded in a different material. These chaos terrains have inspired debate for decades. They might involve partial melting within the ice shell, pockets of liquid water, warm ice rising, or disruption from below. They may not require direct ocean exposure, but they still suggest that the shell can behave in complex ways. For astrobiology, complexity matters because it creates pathways and environments. A shell with internal water pockets could be important even if the main ocean remains deep. Such pockets might store brines, concentrate chemicals, or record exchange processes. They could also confuse interpretation, because material on the surface might come from shallow reservoirs rather than the global ocean. Europa is not simply ice on top, ocean below. It may be layered, messy, transitional, and dynamic. The more scientists learn, the less useful simple cartoons become. That is good for science and difficult for storytelling. A simple story says, a better story says ice, radiation, stress, brine salts, ocean, rock, energy, uncertainty. The better story is harder to sell, but it is closer to the moon. And the moon deserves the harder story. The dark ocean beneath Europa is often described as if it were waiting. That is human language, of course. Worlds do not wait, they are. The ocean, if it exists as expected, has been moving in darkness for ages, long before humans had telescopes, long before life on Earth became aware of Jupiter as anything more than a bright wandering point. It did not begin when we noticed it. It will not reveal itself because we want it to. Exploration is not a conversation between equals. It is a careful act of listening to something that does not speak. The instruments we send must translate physical processes into human meaning. A magnetic perturbation becomes evidence of a conductive ocean. A radar echo becomes a possible boundary within ice. A spectral absorption becomes a surface compound. A gravity anomaly becomes an interior structure. None of these are simple. Each requires models. Models require assumptions. Assumptions require tests. That is why different studies can disagree without anyone being dishonest. Europa's seafloor energy, shell thickness, ocean composition, and surface exchange are all active scientific questions. A new analysis may weaken one pathway for habitability while leaving others open. A measurement may support a thick shell, making access harder, while another may reveal active resurfacing, keeping exchange possible. The public often wants science to move like a courtroom verdict. Planetary science often moves like a fog lifting unevenly over a landscape. Some shapes sharpen early, others remain hidden. What is already clear is that Europa is not a fantasy invented by wishful thinking. The evidence for an ocean is grounded in physics and spacecraft observations. The reason to send a mission is not popular excitement alone, it is a coherent scientific case. A likely global ocean, a rocky interior, tidal heating, surface chemistry, and geological activity. That combination is rare enough to justify extraordinary effort. What is not clear is whether that combination becomes biology. That is the line. A mature story about Europa must live on that line without crossing it. The emotional pull of alien life is powerful because the discovery would answer an ancient loneliness. Humans have always looked up and filled the sky with meaning. Gods, omens, spheres, canals, civilizations, signals. Each era projects its own hopes into darkness. Modern science has replaced many fantasies with better questions, but the desire remains. We want a second living world because it would tell us that Earth is not alone in the deepest sense. Europa is one of the few places where that desire can be tested locally. That makes it precious and dangerous. Precious, because it may teach us what living environments can look like beyond Earth. Dangerous, because people may hear ocean and skip straight to life. The right feeling is not certainty, it is pressure. The pressure of being close to a meaningful question without possessing the answer. The pressure of a mission traveling for years toward a place that may either intensify hope or discipline it. The pressure of an ocean that may be habitable but inaccessible. The pressure of knowing that a world can meet several requirements for life and still be empty. There is maturity in accepting that. Science is not less thrilling when it refuses exaggeration. It becomes more thrilling because the stakes remain real. If Europa were a guaranteed living moon, the mission would be a confirmation. It is not, it is a test. Tests can fail, tests can surprise. Tests can reveal that the world is stranger than the theory. The unknown is not decoration. It is the substance of the mission. As Europa Clipper approaches its future encounters, the moon will become less abstract. Regions that were once blurred will become mapped. Compositional questions will sharpen. The ice shell will become a more physical object in scientific models. Possible landing sites, though not Clipper's mission, may be evaluated with better context. The surface will no longer be only a symbol of hidden water. It will become terrain. Terrain changes emotion. A moon that is only a promising ocean world can be imagined too easily. A moon with named regions, mapped fractures, compositional variations, and measured structures becomes harder to simplify. That is where real wonder begins. Not in vague possibility, but in detail. The details may be harsh. Europa's surface is not safe. Radiation would damage electronics and any exposed organic material. A future lander would need to work quickly or shield itself. Biosignatures on the surface, if delivered from below, may be altered by radiation. Material ejected or exposed recently would be more valuable. Young terrains may matter more than ancient ones. Fresh fractures may matter more than smooth old ice. The search becomes tactical. Where has the ocean spoken most recently? That is one of the haunting questions. If the ocean never speaks, if the ice is too sealed, then the surface may only tell a partial story. If it does speak through cracks, brines, plumes, or disrupted terrain, then Europa may offer samples without drilling through the entire shell. Much of the mission's astrobiological importance depends on whether nature has done some of the excavation already. The moon may have opened its own windows, or it may have not. The answer will shape decades of planning. A future Europa lander, if one is pursued, would need to target a place where the surface chemistry is most likely to preserve meaningful material. A future plume sampling mission would need reliable plume activity. A future cryobot would need a landing site, power, sterilization, communication, and confidence that the ocean is worth the attempt. Each step depends on what Clipper learns. The mission is not the end of Europa exploration. It is a gate. It may decide how seriously humanity pursues the Black Ocean. There is something almost mythic in that, but the mechanics are real. A spacecraft built from metal, electronics, propellant, software, shields, antennas, instruments, and human patience will fly through Jupiter's domain to study ice. Its findings may influence whether future generations try to touch an ocean that has never known sunlight. That is not fantasy. That is engineering aimed at one of the oldest questions in biology. Can life begin in darkness? Earth gives a partial answer. Life can survive in darkness, thrive in darkness, build ecosystems away from sunlight. But whether life can begin there remains debated. Some origin of life hypotheses favor hydrothermal systems, mineral surfaces, chemical gradients, and deep environments. Others emphasize cycles that may be more common near surfaces, shorelines, or drying pools. Europa enters that debate because it may offer water and rock without sunlight and without the surface conditions familiar from early Earth. If life is found there one day, it would strengthen the idea that biology can arise in hidden oceans. If no life is found despite favorable conditions, it may point toward missing ingredients. That is why even a negative result would be scientific gold. If we could ever be confident in it, confidence is the hard part. It is much easier to find a clear signal than to prove a world sterile. Europa's ocean may be vast. Life, if present, could be sparse, localized, or confined near chemical sources. A sample from one place might miss it. A surface measurement might not represent the deep ocean. Even a mission that reaches water could face ambiguity. Organic molecules can be abiotic, cell-like structures can be mineral, chemical patterns can mislead. The standard for alien life must be severe. The discovery would have to survive every non-biological explanation. Europa teaches that life detection is not a single instrument reading, it is a case built from context. On Mars, context means geology, ancient water, minerals, organics, and textures. On exoplanets, context means atmospheric chemistry, stellar environment, planetary mass, and alternative gas sources. On Europa, context means ocean, ice, rock, energy, surface processing, and chemical disequilibrium. A biosignature without context is a rumor. A biosignature inside a well-understood environment becomes evidence. Clipper is a context-building mission. That may sound modest, but it is enormous. Without context, any future claim about Europa would be fragile. With context, even a small anomaly could become meaningful. If a future mission found organic material on the surface, Clipper's maps could help determine whether that material came from radiation chemistry, impact delivery, or possible internal exchange. If radar reveals shallow liquid reservoirs, future sampling strategies change. If magnetic data constrain ocean salinity, models of chemistry improve. If surface compounds suggest oxidant delivery, habitability assessments sharpen. Every serious life search begins long before life detection. It begins with learning the world. Europa is a world worth learning slowly. The coldness of Europa is part of its deception. People often associate cold with death, and on the surface that is a fair instinct. But cold can preserve, ice can protect, a thick shell can shield an ocean from radiation and impacts, darkness can stabilize, a frozen lid can maintain pressure and isolate chemistry from destructive surface conditions. The same ice that blocks access may also make the ocean possible. The barrier is also the shelter. This is one of the moon's deepest contradictions. To reach the ocean, the ice is the enemy. To preserve the ocean, the ice may be essential. If life exists below, the shell may be the reason it survives. It keeps the water liquid under pressure. It protects the interior from Jupiter's radiation. It creates stable environment. It may also prevent easy nutrient exchange. Every advantage carries a cost. Europa's habitability is not a checklist, it is a balance. Too much isolation, and the ocean starves. Too much exchange with radiation-processed surface material, and chemistry may become harsh. Too little seafloor activity, and energy runs low. Too much geological violence, and stability may suffer. The real question is not whether Europa has one ingredient, but whether the entire system maintains the right kind of disequilibrium for the right length of time. Life needs a world out of balance. A perfectly stable chemical soup does nothing. A world where energy flows through matter can build complexity. Earth's biosphere is a planetary scale expression of disequilibrium. Oxygen-rich air, reduced compounds, sunlight, geothermal heat, carbon cycle, water cycles, metabolism everywhere. Europa, if habitable, would express disequilibrium in a darker language. Oxidants from the surface meeting reductants from rock. Salts moving through water. Heat rising from below, ice cycling up, chemical gradients in blackness. That is the version of Europa that astrobiologists hope to test. Not a monster ocean, a chemical engine. There may be no animals there even in the most optimistic near-term thinking. If life exists, many scientists would expect microbial-scale biology, perhaps communities linked to chemical energy sources, but even that is speculation. The point is not to imagine creatures. The point is to ask whether a system exists that could sustain metabolism. Life at its foundation is not spectacle. It is chemistry that learned persistence. The public often wants alien life to be visible. The first life beyond Earth may be invisible without microscopes. It may be a metabolic pattern, a molecular imbalance, an isotopic ratio, a suite of organics too organized to explain easily, a cell-like structure in a sample, or a chemical context that refuses abiotic interpretation. Europa, with its hidden ocean, may make the search even subtler. The signs may be degraded by radiation, diluted by ocean volume, trapped under ice, or mixed with non-biological chemistry. Discovery may not look like discovery at first. That is why scientific patience matters more than excitement. A mission may return data that look ambiguous for years. One group may interpret a compound as ocean-derived, another may argue for surface processing. One model may suggest energetic habitability, another may suggest limitations. Instruments may produce results that are powerful but incomplete. Public attention may move on before the deepest implications are understood. Europa's story will not necessarily fit the news cycle. The moon has waited billions of years. It can outlast headlines. What makes Europa emotionally powerful is that it combines two opposite feelings: closeness and distance. It is in our solar system, reachable by spacecraft, bound to a planet we can see in backyard telescopes. Yet its most important environment is sealed away in darkness, perhaps more inaccessible than the surface of many distant planets. We can fly past it, map it, measure it, and still not touch the thing we care about most. This is exploration in a locked room. The key may not exist yet, but the door has cracks. The cracks are literal, and that is why they matter. The surface is not a smooth vault. It has fractures that tell of stress and motion. It has regions that may record internal activity. It has compositions that may be altered by material from below. It has a relationship with Jupiter that keeps forcing energy into the moon. It has enough evidence for an ocean that serious missions are justified. Europa is not hiding behind pure mystery. It is hiding behind a partially readable shell. That partial readability gives science something to work with. There is an old temptation in space exploration to divide worlds into alive and dead. Earth alive, Moon dead. Mars may be once alive, Venus hostile. Europa may be alive, but reality is more textured. A world can be geologically but biologically empty. It can be chemically rich but not living. It can be habitable in some zones and sterile in others. It can preserve the conditions for life without ever crossing into life. It can change over time, becoming more or less favorable. Europa may not have one answer. It may have histories. Perhaps its ocean was more active in the past. Perhaps chemical exchange has varied as the ice shell evolved. Perhaps tidal heating has changed. Perhaps surface materials have moved downward during certain periods and not others. Perhaps habitable niches, if they exist, are intermittent or localized. The search for life must include time as well as space. A world can be promising now, or have been promising before, or become promising later. Clipper will catch Europa in one era of a long story. That should make us careful. A snapshot of a planet can mislead if the processes are slow. The surface age, resurfacing rates, ice shell evolution and ocean chemistry may all carry histories not visible in a single measurement. Europa's present surface may hide older ocean episodes. Its current chemistry may not match its ancient chemistry. A lack of evidence in one place may not erase the possibility of activity elsewhere. Planetary worlds are not static objects in a museum, they are systems. Europa's system is driven by Jupiter in a way Earth is driven by the sun and internal heat. That different matters. On Earth, sunlight powers the surface biosphere and climate. On Europa, if biology exists, its energy would likely come from chemical and geophysical processes. The entire food web, if such a thing exists, would be built from darkness upward. No photosynthesis, no seasons of light, no plants, no surface oxygen produced by life, no sky-driven climate in the familiar sense. That means Europa would not merely host alien life, it would host alien ecology at the deepest conceptual level. But again, this remains conditional. The script of life has not been found there. Only the possible stage. The stage is extraordinary enough. A global ocean under ice around Jupiter is already one of the most dramatic natural environments in the solar system. Whether it is alive or sterile, it forces us to rethink what a world can be. It turns ice from an ending into a beginning. It turns darkness from absence into a possible habitat. It turns a moon from a satellite into a hidden ocean planet. That phrase, ocean planet, can be misleading because Europa is not a planet in the formal sense, but physically, its ocean may be planetary in scale. It may wrap the moon completely. It may contain immense volumes of water. It may interact with an interior and surface in ways that define the moon's evolution. The word moon makes Europa sound secondary. The ocean does not feel secondary. There may be an entire sea under that ice. A sea without sky. The thought stays with people because it touches something older than science. Human beings have always feared deep water. Oceans on Earth are already places of darkness, pressure, and the unknown. We live beside them and still know only portions of them. Europa takes that primal fear and removes the surface. There is no ship above, no birds, no coast, no stars reflected in waves. There is only the sealed deep. Yet science goes toward it, not because it is frightening, but because it is meaningful. The fear is a byproduct of scale. The meaning comes from the possibility that life may not need what we thought it needed. A black ocean under ice can become a test of biology's universality. If life exists there, independent from Earth, then life may be a cosmic process rather than a planetary accident. If life does not exist there despite favorable conditions, then the origin of life may require a narrower doorway. Either answer would change us. That is why Europa matters even before discovery. It sharpens the question of Earth's uniqueness. For centuries, Earth seemed unique because it was the only world known in detail. Then astronomy found other planets, other moons, other atmospheres, other oceans, other organic chemistry. Earth remains the only known living world, but the reasons for its uniqueness are no longer obvious. Is Earth special because it has water? Europa may have more. Is Earth special because it has energy? Europa may have tidal energy. Is Earth special because it has chemistry? Europa may have chemistry. Is Earth special because those things came together in a particular way at a particular time? That is the deeper question. The search for life is not only a search outward, it is a search backward into why life happened here. Europa is a mirror held under ice. It reflects our uncertainty about ourselves. We know life began on Earth, but we do not know exactly how. We know it appeared early in the planet's history, but the pathway from chemistry to biology remains unresolved. We know water was crucial, but not sufficient. We know energy mattered, but not which settings were decisive. We know minerals, carbon compounds, membranes, replication, metabolism, and environmental cycles all enter the discussion, but the origin remains a frontier. So when we study Europa, we are not simply asking whether something lives there. We are asking whether life is the kind of thing that happens twice. Twice would be enough to change the universe. If life independently began on Earth and Europa, within the same solar system, then biology would seem far less miraculous in the narrow sense. It would suggest that given water, chemistry, and energy, life may emerge commonly. If Europa is habitable but sterile, the opposite pressure grows. The universe may have many wet worlds and few living ones. That possibility is just as profound, though less comforting. Comfort cannot guide the search, evidence must. That evidence begins with the ice. The ice is the only part of the ocean world we can currently examine directly from orbit and flyby. It is the cover of the book. It may be damaged, altered, incomplete, and difficult to translate, but it is available. Clipper's instruments will spend their lives reading it. Every ridge, crack, color variation, and radar echo may matter. The moon's surface is not merely a barrier to the ocean, it is the ocean's possible archive. If salts from below reach the surface, they can freeze into the ice and remain as spectral clues. If brines move upward, they can leave stains, textures, or compositional anomalies. If impacts excavate deeper material, fresh deposits may reveal buried chemistry. If radiation modifies compounds, the alteration itself may help scientists start exposure ages and processes. A surface can conceal and reveal at the same time. Europa's surface does both. It hides the water with miles of ice. It reveals that something below may be active enough to matter. The spacecraft will not be alone in this broader effort. Ground-based telescopes, Hubble, Juno, laboratory experiments, theoretical models, and comparisons with icy regions on Earth all feed the Europa story. Scientists simulate radiation chemistry and they model tidal deformation. They study how salts appear in spectra. They test whether organic molecules survive under charged particle bombardment. They model ocean circulation under an ice shell. They debate the thickness and behavior of the shell. A moon becomes a scientific world through many kinds of work. The public sees the spacecraft, behind it are decades of argument. That argument is valuable. Europa's promise has sometimes been stated too cleanly. Ocean plus energy plus chemistry equals life possibility, but each piece is complex. The ocean's existence is strongly supported, yet its exact properties remain uncertain. Energy is plausible, yet its distribution and accessibility matter. Chemistry exists, but whether it forms useful gradients is the central issue. Surface exchange may, but how much and how often remains unsettled. The moon is promising because the ingredients may align. It is uncertain because alignment is everything. A kitchen full of ingredients is not a meal. A planet full of molecules is not a biosphere. A world must organize matter through energy over time. That organization may be rare, or it may be common. Europa is one of the places where we can test the difference. There is no need to exaggerate it. The real stakes are large enough. Imagine the flyby after years of travel. The spacecraft approaches Europa again, and the moon's crescent fills the frame. Jupiter's reflected light catches this ice. The surface is silent but not blank. Long fractures run like frozen light. Dark material fills lines and patches. Somewhere below, unseen, the ocean moves or rests. Instruments collect data at speeds and sensitivities human senses cannot match. Then the moment passes. Back on Earth, the data arrive as numbers. There is no revelation, no cinematic music in the raw measurement, just packets, calibrations, corrections, uncertainties, images, spectra, magnetic readings, radar traces. Scientists compare them to models. They argue about noise. They check instrument behavior. They combine measurements from different flybys. They build maps. They reject simple interpretations. They refine harder ones. This is how a hidden ocean becomes known, not seeing it, but by surrounding it with evidence. The process may seem cold, yet it is one of humanity's most emotional acts. To study Europa is to admit that something important might exist where no human can go. It is to build machines capable of caring, in a scientific sense, about a moon that does not care about. It is to invest years and lifetimes in the possibility that life's story is larger than Earth. That is not sentimentality. It is curiosity disciplined into engineering. Europa demands discipline because the temptation to believe will be constant. Every interesting compound may become a headline. Every possible plume may become an imagined ocean sample. Every warm region may become a future habitat. Every crack may become a doorway. Some of these interpretations may prove useful. Others may. The mission's success will depend on resisting the urge to make each clue carry more than it can bear. Good science does not reduce wonder. It makes wonder harder to destroy. A claim that survives doubt becomes stronger. A moon that remains promising after better data becomes more compelling. If Europa's habitability case strengthens after Clipper, the excitement will be different from hype. It will have passed through measurement. It will have earned seriousness. If the case weakens, that too will be a form of progress. Human beings have to learn not only where life might be, but where it probably is not. The universe is not obligated to be generous, yet Europa remains difficult to dismiss. Its ocean, if global and long-lived, is too important. Its surface, fractured and young in places, is too suggestive. Its tidal environment is too powerful. Its location inside Jupiter's system is too revealing. Even skepticism does not make the moon boring. It makes the question sharper. Exactly what is missing? Exactly what is present? Exactly what would separate a dark, wet, sterile world from a dark, wet, living one? That boundary may be one of the most important boundaries in science. It may not look like a line, it may look like a gradient of chemistry. At the bottom of Earth's oceans, life gathers where gradients are strong. Hot fluid meets cold seawater, reduced chemicals meet oxidants. Minerals form structure. Microbes exploit differences. Energy flows because conditions are not equal. Europa's possible habitability may depend on similar disequilibria, but with different sources and scales. The ocean must have something to do. Chemistry must be pushed. Matter must have pathways. Still water in darkness is not enough. Energetic darkness is the key. That phrase captures Europa better than ocean moon. It is not the water alone. It is whether the dark water is energized. Tidal heating may warm the interior. Water-rock reactions may generate chemical fuels. Surface radiation may create oxidants. Ice dynamics may move material. The entire question is whether these processes connect. Con is life's opening. Isolation is the enemy. If Europa's ocean is chemically isolated from both surface oxidants and rocky reductants, it may be poor in usable energy. If it connects to one source but not the other, the balance may be limited. If it connects slowly but continuously, it could maintain low but persistent energy fluxes. If hydrothermal activity exists, localized ACEs may become possible. If exchange is episodic, habitability may come in pulses. Europa's ocean could be stable and starved. It could be harsh and it could be layered, with different chemistries at different depths. It could have pockets of greater promise and vast regions of emptiness. This is why the simple phrase Europa may support life hides a universe of detail. Support where? Near the seafloor? Within the ice shell, at the ice-ocean interface, in brine pockets, across the ocean generally, during certain eras, around certain chemical sources, at what abundance with what metabolism, for how long? A serious answer cannot be short. The moon is too complex. A black ocean under miles of ice may sound like one environment, but it may contain many. Near the ice ceiling, water may interact with freezing and melting, salts and materials transported from above. Deeper down, pressure and temperature may vary. Circulation patterns may shift. Near the rocky floor, if the ocean reaches it, minerals and heat may shape chemistry. If the seafloor is active enough, vents or diffuse reactions could create gradients. If not, the ocean's chemistry may be more limited. There may be no single Europa ocean. There may be layers of possibility. The mission cannot map all of that directly, but it can help determine whether such complexity is plausible. Radar can reveal structures in the shell. Magnetic data can constrain ocean properties. Surface composition can hint at internal exchange. Geology can show whether the shell has been mobile. Every clue helps build a three-dimensional picture from a two-dimensional surface. That act of reconstruction is one of the great challenges of planetary science. It is also one of its great pleasures. We learn to see what cannot be seen. Jupiter looms over the entire story not only as a heat engine, but as Europa's orbit is regular, the tidal flexing follows rhythms. The surface stress changes with position. Cracks may form in relation to these forces. The moon is not randomly broken. It is shaped by orbital mechanics. A giant planet's gravity writes lines into ice. That is almost poetic, but it is also physics. In the outer solar system, gravity can replace sunlight as the architect of habitability. That idea expands life's possible territory. A planet too far from its star for surface warmth may still host a warm interior. A moon beyond the traditional habitable zone may have liquid water through tides. Worlds once dismissed as frozen may hide oceans. The classic habitable zone remains useful, but it is no longer the whole map. Europa is one reason why the search for life has moved below the surface, below Mars' dry crust, below Enceladus ice, below Europa's shell, perhaps below many icy worlds we barely know. Surface habitability may be the exception, not the rule. Earth's surface is spectacular, but it may not be the most common form of living environment in the universe. That thought is both hopeful and frustrating. If life prefers hidden oceans, then the galaxy may be alive in places we cannot easily detect. The great silence might not mean absence, it might mean burial. Europa does not solve that cosmic silence, but it gives us a nearby way to study the problem. If life can exist beneath ice without producing obvious atmospheric signs, then telescopes searching distant planets may miss entire biospheres. If hidden ocean worlds are sterile, then maybe surface planets like Earth remain more important. Either way, Europa becomes a test case for how broad the search must be. This is why one icy moon can matter to astronomy, biology, geology, and philosophy at once. It is not just an object, it is a question with gravity. The black ocean beneath Europa, if it is as vast as evidence suggests, has never been touched by a human instrument. No probe has tasted it, no camera has looked into it, no microphone has heard its currents. We do not know whether it is silent, turbulent, chemically rich, or biologically empty. We do not know whether its seafloor is active enough to matter. We do not know whether oxidants fall from above. We do not know whether organics persist. We do not know whether life has ever had a chance. But we know enough to send a spacecraft. That is where modern exploration often begins. Not with certainty, but with enough evidence to justify the journey. The journey itself is a statement. A civilization that sends a spacecraft to study a hidden ocean is a civilization that has begun to take life beyond Earth seriously without needing mythology. It does not need flying saucers, it does not need alien faces, it does not need ruins or signals. It can look at ice, gravity, chemistry, and energy and understand that these may be the true language of life's possibility. Europa is not loud, it is not dramatic in the way humans prefer, it is a quiet moon under Jupiter's shadow, asking whether biology can belong to darkness. There is an image that captures the whole problem better than any slogan. Imagine standing on Europa's surface in a protected suit that no current human could realistically use there for long. The ground is hard ice, cracked and dirty with reddish lines. Jupiter fills the sky enormous and silent. There is no wind, no sound except what your suit invents. Radiation is passing through the environment in invisible violence. Beneath your boots, perhaps 10 kilometers down, perhaps more, is an ocean that may contain the answer to one of the oldest human questions. You cannot reach it. You can only know it is there. That is Europa's cruelty. It puts the possible answer close enough to feel real and deep enough to remain hidden. Every future step will be an act of patience. Clippers, flybys, data analysis, possible lander studies, better ice-penetrating technology, planetary protection planning, laboratory simulations. Models revised after real measurements, maybe one day a mission that samples fresh material. Maybe one day a probe that descends. Maybe never. If the challenges prove too large or the evidence too weak, exploration is not guaranteed. It is chosen again and again. Europa will have to earn each future mission through data. Romantic possibility will not be enough. If Clipper finds a thick, stagnant shell with little evidence of exchange and limited chemical promise, enthusiasm may shift elsewhere. If it finds complex ice, promising surface chemistry, strong evidence of ocean surface interaction, and regions where fresh material may be accessible, Europa's priority will grow. The moon's future in human exploration depends on what it reveals. That gives the mission attention no fictional story needs to invent. A hidden ocean is on trial. The evidence will not be simple. The verdict may not arrive in one announcement. But the process has begun. Europa's dark ocean is compelling because it sits at the intersection of everything that makes alien life difficult to search for. It is physically plausible but inaccessible. It is chemically promising but uncertain. It is close but hostile. It is familiar because of water, alien because of ice and darkness. It invites imagination, then punishes exaggeration. That is the kind of world science needs, a world too serious for fantasy and too strange for ordinary thinking. If Europa teaches us that its ocean is not habitable, the lesson will be severe but useful. It will refine our criteria, it will show which assumptions failed. It will help distinguish water worlds that merely look promising from those that truly have active chemistry. If Europa teaches us that its ocean is richly habitable, even without evidence of life, it will become a target of unmatched importance. If it ever teaches us that life exists there, the meaning would exceed any single mission. A living Europa would mean Earth is not alone even within its own solar system. That sentence is so large that it must be protected from premature use. For now, the right sentence is smaller and stronger. Europa may have the conditions needed to support life. That is enough to cross millions of kilometers. Enough to design radar for ice. Enough to shield electronics from Jupiter. Enough to map cracks, salts, and ridges. Enough to ask whether a black ocean under a frozen moon can be a habitat. Enough to make a small icy world one of the most important places humans have ever studied, not because it gives us aliens, because it gives us a real test of where life could be. The test begins with cold. It begins with Jupiter rising like a planet-sized storm over a frozen plain. It begins with radiation striking ice, with fractures cutting through white crust, with hidden saltwater responding to magnetic fields. It begins with a spacecraft racing past, gathering clues too subtle for human senses. It begins with scientists refusing to turn possibility into proof. And below all of it, if the models are right, the ocean remains black. No sunlight, no surface breeze, no easy access, only water, pressure, chemistry, rock, ice, and time. That may sound like an absence. It may be the kind of place where life learns to begin without ever seeing a star, or it may be empty forever. Both possibilities are immense. The power of Europa is that we do not yet know which one is true.